Here's one of our more sophisticated microinjection complete systems, and it features our MINJ-1000 microscope along with Nereshigi micromanipulators on both sides. This is their new, latest, most compact system that combines both hydraulic and motorized manipulators. The motorized and the hydraulic controllers are both integrated into a small micromanipulator. It has Tritech Research's own stage heating system there, the DT3 microscope stage temperature controller, and Nereshigi's latest pneumatic injectors, which have as much control as hydraulic injectors and don't require the oil. And here's the CRI Perkin-Elmer oocyte camera system, which allows for variable polarization microscopy and allows one to analyze the contents inside a cell to see what their orientation is, and in the case of in vitro fertilization, to look at the spindle and its quality in there. This is one of our complete microinjection systems, and now I'm going to show you how easy it is to set it up completely from when you open the box to this complete system. So here's the microscope pretty much as you take it out of the box. It already has the objective lenses installed. The diffusion grating goes in here. The eyepieces get installed. And now the microscope is more or less ready. You attach the power plug in the back here. And now we're going to install the condenser. That just slides into the condenser bracket. This little thing goes in there and you tighten it in place. Now we're going to install some optional micromanipulators. So the bracket comes pre-installed. Here's the Nereshigi micromanipulator. It just slides right on this little thing here with a little dovetail on the bottom. And you position it so that it lines up with the back of the bracket, and then just use any little rod that you can to stick into these things and rotate them around until it gets tight. Like that. The universal joint installs right here, and that's going to hold the pipette holder. What you want to do is orient it so that the pipette holder, when the micromanipulator is in the center of its range of travel, that the pipette holder is pointing at the center of the field of view. Now, as far as the rest of the hookup for this, you'll see that coming from the micromanipulator, there are 3 hydraulic lines and 1 electrical cable. The electrical cable goes into this power supply, and coming out the other side of the power supply is the motor joystick, which has up and down controls here, and the X and Y system works like that with the joystick. The hydraulic lines, which controls the fine movement here, those go to the hydraulic joystick, which attaches to a metal plate here using this screw right here, which slides the magnet closer and farther and locks it into place. Now we're going to install an identical micromanipulator on the opposite side of the microscope. Same thing here. We slide the dovetail over this little bracket here, line it up with the back of the big bracket, and then tighten these little nuts until the thing is locked into position. There we go. We're installing the universal joint to hold the pipette holder on this side as well, lining it up to be pointing towards the center of the field of view. Okay, now we're going to install Narishige's IM-11-2 micro-injection controller. This is a new system which has a very low dead volume, so even though it's a pneumatic system, it has almost as much control as you would have with a hydraulic system. So it's new and improved in that it uses these quick connects. So the way you install the tubing is you just push it in, and then you pull it out and it locks into place. If you ever need to remove it, you hold in this gray ring while you're pulling, and then you can pull it out. Then this just clips right into the clip on the universal ball joint, and it's in position for doing injections. And we can set up another one on the other side later. If you ordered one of the Tritech Research Digitherm microscope stage temperature controllers, that's very simple to put on the microscope. You've got the control box and the custom-made heating plate, and all you do is plug in the control box, switch it on. You can follow the manual settings to set the temperature. This one was already warmed up to 37 before I started explaining it to you, so this is the actual temperature of it is 37. And then the dish holder itself just goes right on the microscope. And this is designed that if you have something that can move a multi-well cell culture dish, this fits into the same pattern, and it can move this around on the stage as well. If you ordered your microscope with fluorescence capabilities, it's going to have this horizontal illuminator installed already. And all you have to do is take the mercury arc lamp house, make sure that it has the bulb installed in it, and it goes right here, and this ring fixes it in place. Then this is the optical path where the fluorescence cubes go, and here's the slider assembly. This dovetail fits right into here, and this screws in place on this side, and the other cover cap goes right here on this side. The mercury arc lamp plugs into its power supply, which plugs into the wall, and you're ready to go. If you ordered your microscope system with a camera, this is the camera port right here. Comes covered. You remove the cover, and we'll supply the camera with the appropriate C-mount adapter already attached to it. So that just goes right here. Tighten the set screw and attach whatever power cords the camera requires. In the case of having the microscope set up with an ordinary camera, this is all you need right here is the camera, and you take that out to a computer or whatever type of output device you use. However, in this particular microscope system, the customer ordered a nice, interesting, sophisticated camera called the Oocyte system from Perkin-Elmer, and that has some additional optical components because it does variable polarization. So there's a polarizer which goes up here in the condenser, and then there is an analyzer which goes in the infinity path. So we're going to remove the fluorescent stuff and put this in there. Here's the liquid crystal analyzer. And then the cable from that plugs into the camera itself. And now we're ready to go. If you ordered our anti-vibration plate, then that can be installed at any point. Maybe it's easiest to do at the end so that you know how the weight of the microscope is going to be balanced and how to position the foam feet. We're going to do it right now. Okay, so have someone help you by lifting up the microscope. Position the foam feet appropriately. And then the plate. You want everything to be symmetric. In this case we have since the microscope is heavier on the back, we have the foam feet more towards the back than the front. And then when you lower it down, it shouldn't tilt. And there you go. Now the microscope is dampened for vibration, and we're all ready to use it. I'm going to talk briefly about how to align the microscope optics. You can always call us for more help with that, or read any documentation that you received along with the microscope. So the first thing to do is to center and focus the condenser. Start with the lowest power objective. In this case there's a 10x objective in place, and what you're going to want to do is to close down the field diaphragm to make it as small as possible, and then also first focus the objective on any piece of thing that's in the right plane of focus. Then close it down like I just did, and then you can focus the condenser. And what you want to do is focus it until you can see a sharp edges on the diaphragm, like that. And in this case it's already pretty well centered, but these two knobs right here are for centering it. So if I move this knob, that moves it on this diagonal, and this knob moves it on that diagonal until you get it centered. And then you want to open it up to be bigger than the field of view so that you get a nice even illumination. Now we're going to talk about how to align the Hoffman optics. So initially we were just using a bright field thing in the condenser, but since we're using the 10x Hoffman, we're going to rotate the 10x Hoffman slit into position. Now, if you remove one of the eyepieces and look through the hole, you'll see a slit that can line up over another slit, and depending on the position of them, you can adjust the amount of contrast that you get. When they're fully lined up over each other, then it's very dark like this, and when they're disaligned, you lose contrast. Okay, and then you can do that for each of the objectives. We have it set up so that when you rotate the objectives clockwise, the magnification increases, and when you rotate the condenser counterclockwise, the discs follow their appropriate objective. Okay, so now if we want to put a sample into the heater. It just goes into this well right here, and then we can begin to get the pipettes in the correct position. These are not the glass pipettes, these are metal cleaners that come with the needle holder that are still installed, but for demonstration purposes we'll do that. So pretty much you can change the angle manually and move the things close to the field of view. Then you can use the micro manipulators to actually do something with them. So we can go down, and now they're actually touching a piece of paper that I have in the petri dish, and I can use the hydraulic micro manipulators to push it around. And that's about it. You'll just have to get a feel for how to move things around and position them conveniently for your work. Thank you very much.